Hey everybody, so we're going to take a look at mirrors. This is part one, where we're going to take a look at just plain mirrors for this part. Then we'll move on to spherical mirrors and etc. Alright, and then we'll take a look at lenses after that and so on and so forth. So, the first thing we need to talk about is a parallel or point source versus parallel source. So over here we have our point source, and over here we have our parallel source. So a point source is a source that gives off light in all directions. Okay, you can think of like a regular light bulb. And just to reiterate, we're using the ray model. So all of these are rays, otherwise known as it's the path of a single photon. Right? And there are tons of these coming out every direction. An important thing to notice is that these rays, diverge. It's an important distinction. As they move further away, they also move further from the source. As they move further away from the source, they move further away from each other. Whereas on this side, what we have, is a parallel light source. Or relatively parallel. Most of these have reflectors in them, but they're fairly parallel. And what that means is if you were to point this at a wall, the rays would hit uniformly, or the photons would hit uniformly. Right, so you can think of something this way. So if you take a light bulb and you put it in a room, right, it's going to illuminate the whole room. Whereas if you take a flashlight and put it in a room, it's going to illuminate where you point the flashlight at for most flashlights. All right. As you move away from the point source, you eventually can reach a parallel source. So you can think of the sun, right? The sun, up close, the point source, it emits light in all directions. However, it hits Earth relatively uniformly, and so it acts more like a parallel source. All right, so now we can start to actually talk about formation of images by a plane mirror. And so what happens is when you have an image, or when you have an object rather, right? So this is our object, and normally we denote an object just as an arrow or a caricature, a drawing, etc. And so what happens is this is being bombarded by light in all directions and reflecting that light off. And what we want to know is how our plane mirror, which is this guy right here, is going to interact with that light. And so the left side of this mirror is the reflective side, and the right side is the non-reflective side. And we normally denote that by putting dashes like this. All right, so we'll use a different color. Let's use green, and we'll just say reflective. And this side is non-reflective. You can also notice we have this line drawn through. This is known as our principal axis. It's a way to help ground our ray diagrams, right? And that's really what we're doing. It's called a ray diagram. And so there's a couple of rays that we really want to draw in order to see what image this creates. So the first ray we want to do, and you should have a centimeter stick and a protractor when you're doing these, a straight edge is just as well. The first one we want to do is a ray that is parallel to our principal axis. So that means our ray is going to come off. We can go with yellow. Ray is going to come off and hit the mirror. Right, it's going to travel in that direction. Then we have to ask ourselves, what's the reflected ray going to do? Well, right, we know the rule of reflection is going to bounce off at the same angle it came in at. And so our reflected ray, we can go ahead and we'll use pink for this, is going to come back exactly the same direction. All right, and I'll call this reflected ray 1. All right, now to a viewer outside, this ray is going to look like it's coming from the mirror. However, right, this is the reflective surface. There's no light that goes behind this. Okay? But what we can do is we can draw an extension of the ray. All right? And that's going to look just like this. Okay, really the reflected ray extension. What that does is it shows us what we think, okay, or what we perceive the light to be coming from. So the light looks like it's coming from back here, right? The top of this arrow could be anywhere along this line, which means if we want to know where this image is actually formed and what it looks like, we need to draw a second ray. So our second ray is fairly straightforward. Our second ray is going to go through where our principal axis, this straight line, meets our mirror. Okay, right here. And so again, I'll use, okay, the yellow, and it's going to go straight right here. All right, now, once again, it cannot go through our mirror. All right, it's going to reflect off at this angle. And so we have to ask ourselves, what's that angle? The best way to find it, grab your protractor, okay, if you have a fancy digital one, and you can go in and you can measure what this angle is. Now we can see 20, 21, 22, it's roughly 23, which is also what this digital ruler shows, about 23 degrees, which means it's going to reflect down, okay, below the principal axis at 23 degrees. Right, the principal axis is basically acting like our normal. And so I'll use the purple again for our second reflected ray. Now you'll notice reflected ray 1 and the reflected ray 2 diverge on the left side of the mirror. Okay, they just travel off into nowhere. If you were to stand down here, right, if you were to put an eyeball right here and look, terrible eyeball, give it some lashes. I'm pretty sure it's just getting worse, but you get the idea. Okay, it looks like the ray is coming from anywhere along this path. Okay, anywhere along this path, that's where it looks like it's coming from. And so what happens is where these two extensions meet, okay, is where the top of this arrow, okay, the top of the arrow's image is formed. So our image, ooh, that's rough. That is where our image is formed. Right? And so what we have here is the object, and now what we have is, excuse me, the image. All right, and the image is formed by these extensions. Notice the image is on the opposite side of the mirror. Okay, it looks like it's in the mirror. All right, and what we do is we have names for this. So there's a couple ways that we would describe this image. Okay, the first thing we would do is we would call this image virtual. And so what virtual means is it's on the opposite side, okay, of the mirror where it can't exist, right? There's nothing on this side of the mirror. This side of the mirror is, a wall, wherever you have the mirror hooked up to. This side of the mirror is the real world. So it's living in this virtual world, okay? That also means that it can't be projected onto a screen, okay? You can't see it. It's just, you can see the image in the mirror, but it doesn't exist outside the mirror. The second thing is it's upright, okay? It's standing straight up just like its object, all right? And there's no magnification. It's not larger or smaller, it's the same size. A couple other key points is this right here, A little rough, but that's okay, is our object's distance. And you'll notice that it should be the same as our image distance. Normally what we call this distance of the image is di, and the distance of the object is do. Right, and so everything appears the same size, however, it appears normally flipped or reversed, right? You can think of an ambulance. So why does that occur? And so if we look, you have to remember in this case we only used 2 rays to figure out where our image is formed. In this case we can really look at the fact that there's a lot of rays. You notice each ray, right? It doesn't matter which ray you look at, each ray follows the rule, okay, of reflection. The angle in is equal to the angle out. Now the eye is what we call a detector, right? It allows the photons to enter and registers that a photon is actually there, right? And that's the key, is the fact that when the photon is actually seen, you start to form an image. And so this guy over here is our image, and this guy over here is our object. And the fact is, the image, right, the image is on the virtual side, the back side of the mirror, okay, the non-real land, which is pretty important. All right, so how much of a mirror do you actually need to see an object, right? What if we got rid of this whole section of the mirror? Would we still be able to see this object? Well, as it turns out, yeah. All right, in order to see everything you need to see in a mirror, it's based off where the detector is. Okay, where is your detector? Okay, this can be an eye, it can be a camera, a lot of different things. And so you'll notice if you need to see your head, okay, then the mirror height has to be half the distance between your eye and your head. Right? Same if you want to see your feet. The mirror height has to be half the distance between your eyes and your feet. And that comes directly from this, the angle of reflection, right? Straight from that law. The fact that if you were to draw your normal, okay, call this our normal, you'll see that this angle should be the same as this angle. And therefore, you can see all of yourself. So you really only need a half height mirror. You don't need that full length mirror. Or in fact, you can get a full length mirror, cut it in half, and have 2 mirrors to see yourself. All right? But it's a curious thing that, yeah, you don't need that full mirror, but you do need to stand at the right position. Your eyes have to be at the right place. If you were to duck down or stand above the mirror, you would not be able to see everything. All right, so image classifications, there's a couple classifications, we talked about them. Whenever you look at an image or try to describe an image, there's a couple things you should say. So first, you want to tell me if the image is real or virtual. Okay, so a real image for a mirror, it's going to be on the same side as the object. Okay, where the virtual will be opposite side as the object. Okay, normally that means the real image will be on the reflective side and the virtual image will be on the non-reflective side. And the key again is a real image can be projected. Okay, if you were to take the mirror and reflect this image, you'd be able to see it on a wall. And the virtual image, okay, is not projected. So it's always going to fall into one of those 2 categories. The second thing is you need to tell me if the image is inverted or if it is upright. If it is inverted, okay, the object is flipped, or the image is the flip of the object. Whereas the upright, the image is the same, okay, orientation, flipped orientation, that's really what that should say. Go ahead and correct that. It's the flipped orientation. All right, for upright, the image is the same orientation. Okay, that's the object. And 3, you should talk about the magnification. Is the image larger? Is the image the same size? Or is the image smaller? Right? So in the case of our mirror, our plane mirror that is, right, the object was virtual, so it's on the opposite side of the mirror. It's on the non-reflective side. The object is upright, has the same orientation, or the image has the same orientation as our object, and there's no magnification. They are the same exact size. Right, so you always want to describe your images using these 3 descriptors. All right, so we're going to wrap it up with 2 questions. All right, so first, when an object is placed in front of a plane mirror, the image is upright, magnified, and real, upright, the same size and virtual, inverted, magnified, and real, inverted, magnified, and virtual. So take a second and try this. All right, and the answer is the object is upright, same size, and it is virtual. So if we go back again, right, it's on the other side, virtual, it's upright, same orientation, there's no magnification. It's the same size. All right, one more. Okay, in this case, an object is placed in front of a plane mirror. Here's our object. Which is the correct location of the image produced by the mirror? So where does the observer think the object is? Okay, is it at the mirror? Is it up here? Or is it down here? All right, and the answer is it should appear like it is, okay, down here. And so what happens is you look, here's the observer. This is going to send a light ray this way, and then it's going to bounce into the observer's eye. This is going to send in a light ray this way. Okay, that's a little extreme. Light ray this way and bounce into the observer's eye. What we want to look at is the extensions again. All right, the extension of this guy is going to continue down. A little sloppy, very sloppy, and this extension is going to follow down. And so what you'll see, right, and you can also do the parallel, but the parallel is not going to make it to the person's eye, so you want to look at 2 from the same point, and you'll see that they'll both wind up going down towards C. And so C is where the object will appear to be, okay, when in reality the object is right below the person. All right, so I'll see you next time.